Alright, welcome back my friends. Today we're continuing our adventures with my attempted Mercury vapor glass drum light conversion. So, last time you saw me successfully run my Philips Lifeguard 40-50 watt Mercury vapor lamp off the ballast of my F30T12 fluorescent strip light. And I said that I was going to get a dedicated ballast that I could put inside this fixture. And the ballast I got is right here. Got it for Christmas. This is an Advance model L140FTP. This is a preheat magnetic fluorescent lamp ballast for one F40T12, F30T12, or F30T8 fluorescent lamp. And this this particular model of ballast has proven very successful in running 50 watt mercury vapor lamps. So that's what I decided to get. And Mom got me this for Christmas from eBay. I think it was like 15 bucks or something like that. Interestingly, it was sold as a new, never used ballast, but as you can see, the label is very dingy. And interestingly, after she bought it, apparently the seller of the ballast kept repeatedly sending Mum emails telling her not to worry that the label was all scratched up. So that in itself makes one kind of suspicious. But maybe it has never been used and it's just, sat around and that's why it got so beaten up. Because the wires are still folded, so it may have never been used, but at any rate, that doesn't matter. I don't care even if it was used. It works, and that's fine by me. What I'll show you first is this ballast working on its intended load, a fluorescent lamp. So what I'll do is I'll grab my 1980 Sylvania F30T12 lamp from the strip light there, and I'll rig it up to this ballast, and you'll get to see it start up. You'll get to see a preheat start up. Alright, a couple minutes later I got everything wired up. Pretty simple to wire up one of these auto transformer preheat ballasts. What you do is you got 3 wires coming out of it, black, white, and blue. Well, the black and white's pretty simple. They just hook up to power, your hot and neutral of your power line. And the white wire, the neutral, coming from your power line, also goes into one end of the lamp. So I also have this orange wire coming connected to the white wire of power here, and that goes into this jumper clip, which just goes into one pin on one end of the lamp. Your blue wire goes onto one pin of the other end of the lamp, and that's how it works. For preheating, you just need a starter connected between the other pin of one end of the lamp and the other pin of the other end of the lamp. Now, I don't have a suitable starter for a lamp as large as this. I could use the starter from my 4 watt preheat strip light, and even though it works, the problem is once the lamp actually starts, the starter doesn't deactivate. It just keeps preheating it over and over and over. So to preheat it, I'm going to do a manual preheat. I've just got a wire here, 2 connected together to make it long enough. And to preheat it, I just take this wire and I touch it to the other pin on the other end of the lamp. And I just do that, hold that there for a couple of seconds, let go, and the lamp starts. Alright, so it's plugged in and I'll turn it on. Now, when I turn it on, you might see the lamp glow very dimly. That's not going to do it this time. I'll take the wire here and preheat it, and you'll see the cathode glow and some spark maybe. Oh, there. Didn't take any preheating time to start. There it is, running. And the ballast does hum a bit. You'd have to be close to it to hear it. Works just fine. Now, I can take the wire here and put on the preheat mode again. There you can see the filament glowing. This is a nice preheat ballast in that it doesn't make the filaments glow hot enough that an arc strikes across them, which is good. Now if I turn this off and turn it back on, there you can see the lamp glowing very dimly. I'll just preheat it again, and we're running. So, we know now that the ballast indeed works. Cool. Now we need to figure out a way how to get this ballast into this fixture. What I was hoping for when I first got this fixture was that I could fit it in this space here, which I found a way to get access to. But unfortunately, this thing's like half an inch too high. So, well, it looks on the outside like it should fit, but no, because the wall actually starts right about there. So this won't fit in there, but I did find something that should fit rather well. So I'll take the glass dome off here. Once the glass dome and the bulb are removed, I found that if I take this secondary lamp holder out, which I was hoping I could use for like an incandescent or something, but forget it, I'll do it for the sake of making this ballast work. If I take this secondary lamp holder out, I can use this screw hole right here as one mounting hole for the ballast, for that hole right there, and for the other hole, I was hoping I could use this screw over here, but it won't fit, not far enough away. And that one there won't work either, it's just barely too close as well. But I figured I can have the ballast sitting like this inside the chamber. And there's a good amount of clearance between the bulb and the ballast. And just drill another hole there. It's just, you know, metal isn't too terribly thick, so shouldn't be too hard to drill another hole there. And I found a nut and bolt. Well, it's actually not a bolt, it's a screw, I guess. But the nut fits it perfectly. And it should work very fine once I drill a hole of the correct size. Now, I can show you how this takes apart. On the back here, there's a couple of nuts that you undo. But top plate comes off like that. And interestingly, while this thing is quite rusty on this side, it's very good on this side, strangely enough, and it's very good underneath as well. But here's inside of the chamber that I was hoping I could put the ballast in, but it's too high, won't fit. Oh well. I can remove this secondary lamp holder, which is this one right here, by undoing this bolt here. Which, oh no, I can do it by hand, because I've already done this already. And lamp holder comes right out. And where'd the screw go? Ah, there's the screw. Or the bolt, I guess. Well, I guess it's a screw. Could be anything. But, second lamp holder just pulls out. Man, I hope I can improve my camera work with these new cameras. But there's a second lamp holder, which will be a nice spare, nice porcelain lamp holder. And ballast can mount right there with that hole there. And I'll drill a hole right there for the other mounting place. So the ballast will sit like this. And the bulb will screw like this. And the wires going to the other lamp holder, I'll thread them out through here so they can no, actually I'll take the wires from the ballast and put them inside the chamber, and that'll be a lot neater. So should work quite well. So what I'll do right now is, and God help me, because you guys probably know how my carpentry skills are and skills with tools and stuff, but I'm going to take this down in the basement and drill a hole right there. And what I'll do is, I should mark that hole, shouldn't I? Get my Sharpie here. Right there. Perfect. Well, that worked quite well actually. Had it done in about 5 minutes. It was pretty effortless. There's the hole right there, and my bolt goes right in there. Perfect. Alright, ballast is secured. Perfect. The nuts are in, and it's nice and secure. It's not going anywhere. Awesome. I thought there would be some sort of obstacle to getting this done, but no, everything's going very smoothly. This should be up and running in no time. Perfect. Well, I figured something must go wrong since I said nothing would. I'm an idiot. I forgot that the glass drum has to fit in between the ballast and the edge of the fixture, and I did not leave enough room for that when I mounted the ballast. So what I gotta do is I gotta drill another hole. I'm gonna position the ballast farther away and drill a new hole. Shouldn't be a big problem, although I was hoping I wouldn't have to drill any extra holes. But well, it's not a big problem, just a little snag. So I'll go do that, drill a new hole, and then I'll come back. Or maybe not. I completely forgot I can do this. There. Just use that lip right there. Put the bolt in, and I think it'll allow the ballast to wiggle around a bit, but it won't wiggle up and down, so it's not going anywhere, and there is enough room there. I tried it, so that should be perfect. No new holes needed. Alright, I threaded all the wires out the back of the fixture in the middle chamber here. And how it works is I just got the blue wire coming from the ballast going into the black wire of the lamp holder. And I've got the white wire of the lamp holder, the white wire of the ballast, and the white power wire all connected together. And I've got the black wire of the ballast and the black wire of the power connected together. And ground I will find a place on here so I can attach it against the fixture. So when you look at the business end of it here, I don't know about you, but to me this looks pretty slick looking. All the wires there going out that hole, and the blue wire going out that hole, and it looks pretty slick. And the power cord, I've tied a knot in it so you can't accidentally yank on the cord and cause a bunch of problems. And because I'm short on wire nuts, the one here is a little bit too small, and these two are a bit too large, but they all hold just fine. So until I get some new wire nuts, I won't worry about it. So I'll put this all back together, and then we'll come back. Alright, here's the final product, and yeah, I'm really impressed. I really like how this turned out. I'm very pleased. And you got the power cord here. So let's screw the bulb in, just like that. And let's plug it in and try it out. Alright, it's plugged in. Get ready to hit the switch. 3, 2, 1, contact. Perfect. The only reason I wish I could have put the ballast inside the fixture instead of on top here is so when you had the cover on, you wouldn't see the ballast in there. But I guess it's okay. Oh, actually, before I continue, let's actually plug it into my kilowatt. This is a new kilowatt meter which I got this Christmas. When we had men working in the basement, I had my kilowatt plugged into the sump pump, and when a company came to replace the sump pump, my kilowatt meter magically disappeared. I called the guy that was there, and he said there was no kilowatt meter around. The old pump wasn't plugged into one, but I don't know. I think someone got some sticky fingers, but anyway, I'll plug that into my kilowatt, and just so we can see, you know, like how many watts is being drawn and stuff. Alright, let's go again. There's our voltage. There's the amperage being drawn from the ballast. It's a low power factor ballast, so it draws quite a bit of amperage for the amount of power you get. Currently drawing 26 watts in some, 114 volt amps. There's our frequency and the power factor. Very low power factor right now. When the lamp's fully warmed up, it'll be about 0.45 or so. Actually, what I will do here is I'll give a very brief, just very brief, because there are websites on the internet that'll be able to tell you a lot better, but a very brief explanation of what power factor is. With AC power, you just don't have power, but you also have what is called volt amps reactive, which is basically also known as reactive power. So you have just power, which is called real power, and you have reactive power. And basically what reactive power is, see, I don't know physically how it works, I only know mathematically how it works, but from my understanding, basically it's power that the load bounces back to the generator supplying the power. So basically power that a device like this would send back to the generating station that provides this house with power. See, with DC power, it's quite simple if you want to calculate power. It's just voltage times amperage, your current, voltage times current. But with an AC system, it's actually voltage times current times your power factor. So this 29 watts that it's showing right now, that's the 121 volts multiplied by 0.91 amps multiplied by 0.26 power factor. If I were to do just voltage times amperage, so the 121 times the 0.91, you get the volt amps, 110. And volt amps comprises of your power and your reactive power. That's basically how it works. And from my understanding, reactive power is not dissipated like heat. You know, for example, this whole system right now is dissipating about 31 watts of power. And a lot of that power, you know, it's being dissipated as heat from the ballast, and it's also being dissipated as light from the bulb, and also quite a bit of heat from the bulb. But your reactive power is not dissipated in the form of heat or light or any form of energy. It's just sent right back to the generating station. Now, the whole reason to be concerned about power factor at all is because if you have a load, such as this one right now, that has a very low power factor, the power factor of this is only 0.3, that's quite low, that means that, as I mentioned before, you're using a lot of current for the amount of power you're using. If this were a high power factor ballast, it would use the same amount of power, let's say 33 watts, but the current would be a lot less. It wouldn't be 0.85, it'd be a lot lower. So the problem is, if you have a low power factor load, that means you're using energy that you're not paying for. Compare a load that has a high power factor and uses 100 watts of power, and a load that has a low power factor and uses 100 watts of power. Well, they're dissipating the same amount of power, but the low power factor load is drawing a lot more current to do it. But because they're both using the same amount of power, you're paying the same electricity bill for both of them. So when you have a low power factor load, you're using extra current from the power company, but you're not paying for it. You don't have to pay for it. And the power company, of course, doesn't like that. They have to do extra work that you don't have to pay for. So as a result, you know, for household and residential areas, you know, power factor, you know, they don't really care about it. In a commercial environment, though, such as a factory that uses a lot of power, the power company does keep an eye on you to make sure you're keeping a reasonable power factor. If your power factor is too low, the power company will actually fine you for it. Likewise, if you keep a very good power factor, some power companies reward you for it. They give you credit. So that's the whole power factor thing, and that's why there are low power factor, normal power factor, and high power factor fluorescent lamp ballasts. Ballasts that are usually destined for the home market, they're low power factor, much like this ballast. But you can also get ballasts that are high power factor that were made for the commercial market. For example, the ballast in my 30 watt strip light is high power factor. It was specifically designed to have a better power factor. So that's just a very basic description of how power factor works. Like I said, I don't actually know how it works practically. I only know how it works mathematically from school. So don't take any of that as gospel, but I think on a very high basic level, it should be a good idea of what it is. And you may notice, even though our wattage is going up right now we're at 36 watts. When we last looked, we were at 31 or so. Our current has gone down. How does that happen? See, as the wattage is going up, it's still going up. The current's dropping. Well, that's because the power factor's rising. So there you go. We're at a 0.4 power factor. When we last looked, we were at a 0.3 power factor and drawing a lot more current, even though we had less wattage. So there you go. And of course, the reason not all fluorescent lamp ballasts are high power factor is because it costs more money to make them high power factor. A high power factor fluorescent lamp ballast uses a capacitor. It has a capacitor, and that raises the power factor. A low power factor ballast does not have such a capacitor in it. And that, of course, makes it simpler and cheaper to manufacture. Alright, we've been running for a little over 15 minutes now. The bulb is fully warmed up. You can see it there. And everything's running good. The ballast is warm, but doesn't feel dangerously so. As for our specs, we're drawing 0.68 amps. We're getting just over 39 watts. And our power factor is 0.47. That's after 16 minutes of running. And yeah, it's doing pretty good. So if we're getting a little over 39 watts of power, then the bulb's probably getting at the most 35 watts, probably closer to 30. But it's doing just fine nonetheless. And actually, I think this ballast actually drives the bulb with less power than the ballast in my F30 T12 strip light does, which I found kind of surprising because this is a preheat ballast, and usually preheat ballasts drive their respective bulbs at full power, whereas my strip light is a rapid start ballast, which usually slightly underdrive lamps. Of course, I know just by looking that the ballast in my strip light drives an F30 T12 at full power, but a Mercury vapor lamp, which emulates a lamp just slightly bigger than an F40 T12, I figured would be underdriven on that ballast and driven a bit better on this ballast. But I think the ballast from my strip light actually drives this bulb a bit harder than this ballast does, which I find very surprising. And perhaps that's a testament between a old ballast and a new ballast. The ballast in my strip light's from I think around 1971, and then this ballast I think is from around 1998. It has a date code on it, which is the complicated style that Advanced started using in like the late 90s or so, that I don't think people on Lighting Gallery know how to decode. But it does say on the label here 120398, so I'm thinking this ballast was probably made in 1998. But I guess that's a testament between old and new ballasts. But this ballast is doing a good job nonetheless. Just slightly warm, and the bulb seems to be pretty happy, and that's it. So before I go, I'll put the glass drum back on so you can see what that'll look like. There you go. That's what it looks like. So there is pretty much the final version of my 50 watt Mercury Vapor glass drum light fixture conversion. Very successful, I'd say. Powered by an F40 T12 magnetic preheat fluorescent lamp ballast. Very successful, I'd say. I'm very pleased with how this turned out. So I don't know what I'm going to do with this now. I can't install it here because I can't, drill anything into the ceiling. I could do it in the basement, but of course I'm never in the basement, so that wouldn't be much fun. It would hardly ever get any use. Or I could just set it on top of my shelf somewhere, and it would be just fine there. I'll figure something out, but until then, this fixture is pretty cool. I'm very happy with it. Happy with how it turned out. So there you guys go. Hope you enjoyed. Thanks for hanging out with me today, and I will see you guys next time.